Today we're going to talk about condensing logarithms. So first thing I want to note is that the coefficient of a log has to be 1 before you can do any condensing. So if you got something out front being multiplied, you got to handle that business first. And then the second thing is you're just going to use all those log rules backwards. So I took the liberty of writing them backwards for you. So if you have the log base b of m plus the log base b of n, you can change that to the log base b of mn. The log base b of m minus the log base b of n can be changed to log base b of m over n, or m divided by n. And then p times the log base b of m is the same thing as the log base b of m to the p. All right, so let's do some examples. For the first one, we have the log base b of j plus the log base b of k. They're being added. The bases are the same. So if I use my property backwards, I can change it from a sum to a product. So that'll be the log base b of j times k. And that's it. Let's look at the next one. We have 3 times the log base the log base m of p minus the log base m of n. Before I can condense, I have to handle this coefficient. So remember, we can move this up here to be a power. So now we have the log base m of p to the 3 minus the log base m of n. And when it's subtraction, we can change it to a quotient. So that is equivalent to the log base m of p to the 3 divided by n. Finished. Let's look at the next one. We have the log base 5 of x minus 7 minus the log base 5 of x minus 8. So this is subtraction, so we can change that to division. So this is equivalent to the log base 5 of x minus 7 divided by x minus 8. And I can't simplify that, so I'm done. Just want to point out, to do the condensing, the bases of the logarithms have to be the same. Let's look at another one. All right, we have 2 times the log base y of 6 plus the log base y of 3. So first we got to handle that 2. Gonna move it up here to be a power of 6, or an exponent with 6. So we have the log base y of 6 squared plus the log base y of 3. Now when it's addition, we can change it to a product. So that'll be the log base y of 6 squared times 3. And we can go ahead and simplify that, right? So that'll be the log base y of 6 squared is 36 times 3, which will be the log base y of 108. Done with that. All right, let's look at the next one. We have a 7 and a 1/3 for a coefficient, so we got to handle that business first. So I'm going to move the 7 for a power and the 1/3. So that'll be the natural log of y to the 7th minus the natural log of x to the 1/3. Now we don't generally leave our exponents as fractions, so let's change that to a radical. So that's the natural log of y to the 7th minus the natural log. A 1/3 power is the same as the cube root of x. And it's subtraction, so we can change it to a quotient. So that'll be the natural log of y to the 7th divided by the cube root of x. And I'm okay with that radical being in the denominator. I'm going to leave it just like that. All right, let's look at another one. We have the log of 6x minus the log of 6. It's subtraction, so I can change it to a quotient. No coefficient, so I don't have to worry about that. So that'll be the log of 6x divided by 6. Now, these two 6's will cancel out. So I can think of this as just the log of x. All right, let's do another one. We have 2 times the log base 3 of 9 minus the log base 3 of 27. You could simplify those right now. I'm going to go ahead and just use our condensing properties. So I'm going to make that a power. So we'll have the log base 3 of 9 squared minus the log base 3 of 27. And then this is subtraction, so I can change it to a quotient. So that would be the log base 3 of 9 squared divided by 27. Well, we all know 9 squared is just 81, right? So that's the log base 3 of 81 divided by 27 is 3. And the log base 3 of 3 would be 1. And like I said, I could have simplified that up here, but just to have fun. And let's do one more. We have the natural log of x minus 2 plus 5 times the natural log of x. All right, we got to take care of that coefficient. Going to move that up there. So we'll have the natural log of x minus 2 plus the natural log of x to the 5th. So you need to multiply these or change it to a product. So that's the natural log of x to the 5th times x minus 2. You could leave that like that, or if you just felt you wanted to continue, I could distribute, and that could be the natural log of x to the 6th minus 2x to the 5th. All right, and that's it for today. Have a wonderful afternoon.